we're going to connect sensors to the robot. And to do that, we're going to use the general purpose input-output pins, or GPIO pins, that are on the Photon breadboard. So you'll notice that on the shield, there are a whole bunch of pins that are labeled that don't have to do with the motors. And that's because the shield itself is designed to connect to motors, but because it's in the Arduino shield form factor, it also includes these headers which connect across these stacking headers to the board for pins that are in the exact same position, and they're labeled for our convenience. So you'll see that there are these digital pins 0 through 13, as well as one that says SCL, which connects to a pin underneath it on the logic board that also says SCL. And then there are a whole bunch of pins over here that have to do with power. Specifically, we have a 5-volt power supply for supplying 5 volts of DC power to any additional devices. We have a ground, which connects to the ground that eventually leads back to our battery's ground. And then we have these analog pins over here. So what kind of devices can we connect? Well, the device we're going to work with right now is this temperature sensor, and it's on what's called a breakout board. The sensor itself is that square chip in the very center, but for convenience it's attached to this breakout board, which allows us to access the different pins and provide it power and read data from it using jumper wires, these jumper wires right here. So if we read what the pins are labeled from left to right, we'll see one that says VCC, and VCC or VIN typically means that it needs power supplied to the chip from our Arduino board or Arduino shield from the 5-volt or 3-volt pin. Then we have the GND for the ground return, and then we have 2 pins that say SDA and SCL. Anytime you see SDA and SCL, you're looking at a device that's what's called an I2C device, and it uses a protocol that typically we can use a library to figure out how to access those device functions. So now to make the connection. To make it easier to make the connection, we have to use our jumper wires. But we're also going to use a breadboard. And a breadboard is a way of quickly making connections. And the way to think of a breadboard is that there are all these separate rows, and I see a whole bunch of rows here. There's a dividing point at which there's no connection between the rows on the left half and the rows on the right half. And anything that's plugged into the same row is connected to anything else on the same row. Therefore, if I took this red wire and plugged it in over here, and then I also took this red wire and plugged it in on the same row, both red wires would be connected to each other. So electrically, any voltage flowing through here would come out over on this side if this is leading towards the ground eventually. Now, columns are not connected to each other. So if I took this blue wire and plugged it in over here, like so, then this blue wire is not connected to any of the red wires. Only rows are connected, so columns are not connected to each other. Why is this important? Well, eventually you may find yourself in a situation where you need to supply power to more than one device and a ground to more than one device. So that way I can take these and send them back to the Arduino or the Photon and have a ground and a 5-volt power. And I can have multiple grounds and 5-volt powers coming out of there and supply power and grounds to every single one of the devices. Every device, if it receives 5-volt power or 3-volt power, it also requires a ground, and the ground has to go back to the same location. So this is, think of it like a junction board for us to send all those powers and grounds back. I'm going to go ahead and place the breakout board over on this half over here. And I'll go ahead and make the first connection. And I'm going to zoom in so that you can see. So the first thing is I want this blue ground connection to go into the same pin or same row that the ground pin is on. And then I'm going to take the red and plug it in over here for VCC. And this is eventually going to lead to my 5-volt power. As a matter of just consistency, we tend to use red to represent the current or the supply current and blue to represent ground, but you can also use black. And really the colors don't matter so long as they lead to the correct location. So those are the first things that I want to plug in. Now there is no power running to this yet. So the next thing I need to do is connect the opposite end of the breadboard to the actual device itself or to the robot. So on the robot, let's go ahead and take a look at those ground pins and 5-volt pins again. I want the red wire to connect into the 5-volt header, and I can see the 5-volt header is right there. So I'll make that connection. And now I have 5-volt power that will go to my device, and I'll also need the ground. It's common to have a lot of different grounds, and therefore the Arduino or the Photon Breadboard will typically have more than one ground, and there are grounds in multiple locations. But I use a breadboard just because it allows us to essentially create multiple grounds that only require one connection into one ground pin. But those are the connections that are required to power the device. Now, for the other two connections, which say SDA and SCL, those are pretty straightforward. All I have to do is connect the SDA and SCL connections to directly to the Arduino. If I wanted to, for SDA and SCL, it's possible to connect multiple I2C devices to the same SDA and SCL GPIO pins. But for now, I only have one, so I'm just going to go ahead and skip straight to the end and bypass the rest of the breadboard and not create a separate connection, so that I have like I'm only going to use one connection. So I have my yellow wire leading to SDA, my green wire leading to SCL, and it's straightforward. On the robot itself, my green wire, which was SCL, is going to connect directly to the SCL pin over here. And you don't see the SDA pin labeled on this particular shield, but they're typically going to be the exact same. They're going to be in the exact same locations right next to each other. So there we go, and that's how to make the connection between a sensor and the shield. Later on, you're going to try making that sensor connection with a ultrasonic sensor, and these work slightly differently, but if you look inside of the curriculum text, it'll say which pins connect to what, and notice that it does still have a VCC and a ground pin. Now, because I've already used the 5-volt VCC connection on this shield, I'm going to have to go ahead and also connect it to these rows on the breadboard so that I can draw power from the same source.